This is the 2023 paper 1 and it's a non-calculator paper. So question 1 worth 2 marks. It says Josh earns £9 per hour and works 30 hours a week. His weekly outgoings are £220 a week. Josh saves all his remaining money. He books a holiday costing £566. He will take £800 spending money with him. Calculate the minimum number of weeks it will take him to save the total amount. So first thing we've got to do is we've got to deal with this, how much he actually earns, outgoings and how much he uses of his salary that he's got to pay out for insurance or mortgage or rent or whatever it may be. So if we deal with these two things, we can work out how much money he's got left. So that will be the remaining money, and then we'll see how much he needs for his holiday. So he earns, and the first thing is he has got £9 per hour. And he works for 30 hours, so he gets that £9 paid 30 times, so it's times by 30. 3 9s are 27, so we put down 27 and stick a 0 on there. So he earns £270 per week. His outgoings are 220, so for his outgoings, we've got to take that away, and we'll see what he's left with. So outgoings, we've got to deduct £220. So when I take them away, I'm left with £50. So it means that Josh has got £50 every week to save towards his holiday. So we're now going to work out how much he needs for his holiday. So we'll take another wee subheading and we'll say holiday. And he needs £566 to pay for the holiday itself. But he's decided he needs £800 spending money. So when we add them together, 6 and nothing is 6, 6 and nothing is 6, 8 and 5 is 13. So that's how much he needs. That's how much he needs to save. Now we know that he can save £50 every week. So we could make this easy for ourselves and we could say, so that means that he can save £100 every 2 weeks. And it might be easier to deal with it that way. So we can save £100 every 2 weeks. Okay, so we're going to go to the amount of money that he needs. He needs basically 1,366. Now that's the same as 1,366. I'm going to round that because it's not an even amount. So we're going to make that 1,400. Now I know that he can save £100 every week. So there's 14 lots of 100 there. So therefore, every 2 weeks he saves 100, sorry. So that means that we've got 1400. So that's going to take me 2 lots of 14 for the number of weeks. So the number of weeks is going to be equal to 2 times 14, which is equal to 28 weeks. So it's only worth 2 marks, so we're not expected to do division sums and things like that. So you're looking at how much he needs. He can save £50. The easiest way to do that is to say, well, okay, we can do £100 in every 2 weeks. So we want to know how many £100 are in that. There's £1,400 in there. So the number of weeks is, it's going to take him 2 weeks for each one of them, so it's 28. A speedometer is shown, the lorry speed is restricted to 56 miles per hour as a maximum. We've got to use speedometer to determine speed in kilometres per hour. I've already drawn this one in. So you look for 56, there it's there, put a wee dot on it, go to the start bit of your speedometer, that's where the wee needle is coming out, and draw a straight line up there. And when I draw a line up there, I'm reading this scale here, which is in kilometres per hour, and I can see it's hitting 90 miles per hour. Make sure you draw a straight line through them, you don't try and guess. Question 3, it says the crowd at a rugby match was made up of home supporters, away supporters and people who were neutral. 3/7 for home supporters, 2/5 for away supporters, the remaining people were neutral. Calculate the fraction of the crowd that were neutral. This type of question comes up in almost every paper. So you're going to add up the 2 fractions, the amount you've got. So we're going to add 3/7 and 2/5. You can do the smile and kiss method. So there's a smile, we multiply 7 and 5 together to give us 35, that's our lowest common denominator. Then we do the kiss part, so we cross 5 over there and do 5 times 3 is 15, and we cross across there, 2 times 7 is 14. So now I've got fractions with the same denominator, that makes it easy. because I can just add the numerators. So I end up with 29/35. Now that's the total of them and them, but it's the remaining amount that we're neutral. So we've got 29/35. So I've got to start off with the whole amount. So the whole amount would have been 35/35. So that's the amount to start with. That's a whole number. That's one lot. And I want to take away the 29/35. Same denominators, dead easy. Just do the sum at the top. So 35 take away 29 leaves us with 6. So it's 6/35. That will be the crowd that they're neutral. Those questions come up all the time where you're adding two fractions and taking it away from one whole number. Geoffrey shared his savings between his three children, Sophie, Ed and Lucy. The money was shared in the ratio of 7:2:6. Sophie received £3,304. Calculate how much money Geoffrey gave his three children. So there was Sophie, there was Ed, and there was Lucy. And they were shared in the ratio of 7:2:6. Then it tells us Sophie got £3,304, so we'll write that underneath Sophie's heading, so she got £3,304. We've got to work out how much Ed got and how much Lucy got. So what we can do is we can say, well, 7 shares gave Sophie that amount. So we'll work out what each share is worth. So I want to know what a share is. Okay, so each share is, and it's going to be £3,304 divided by 7. So 3 divided by 7 doesn't go, carry it across. 33 divided by 7, 7 4 is 28, and that leaves us with 5 left over. 50 divided by 7, 7 sevens are 49, and 1 left over, and 14 divided by 7 is 2. So each share is worth £472. Now you could do 472 times 2, 6 times 472, and then add them all up, or else, probably easier, you can say, right, each share is worth £472. How many shares did they have in total? They had 7 plus 2 is 9, plus another 6 is 15. So there was 15 lots of them. Now it is a long multiplication, so if you're happier timesing 472 by 2 and 472 by 6 and adding them up, then that's okay. I'm going to do it this way. So 5 2s are 10, put down the nothing, carry 1. 5 7s are 35 and 1 makes 36, put down the 6, carry 3. 5 4s are 20 and 3 makes 23. Now we've then got to multiply by the 1, but because that 1 stands for 10, we put a 0. And we do 1 times 2 is 2, 1 times 7 is 7, 1 times 4 is 4. Now we're going to add them up. 6 and 2 is 8, 3 and 7 is 10, carry 1, 4 and 1 is 5, and 2 makes 7. So basically, Geoffrey had £7,080 that he shared between his children. Question 5. Eddie runs a stall at a school fundraiser. His game requires 2 spinners to be spun and allowed to come to rest. The spinners are shown. So there's one with red, blue, red, yellow and green. The other spinner has got numbers 1 to 5 on it. So the question is, a prize is won if one spinner lands on blue or green and the other spinner lands on an even number. Calculate the probability of not winning a prize. Okay. So it says a prize is won if the spinner lands in blue or green and the other spinner lands on an even number. So we're going to start with this spinner. So there's a red one, there is a green one, there's a yellow one, then there's another red, and then there's a blue. So what's the combinations? That's everything I can get from that first spinner. Now on this one I could then get a 1, 2, 3, 4, 5. So I could have red with a 1, a 2, a 3, a 4 or a 5. I can have that green with a 1, a 2, a 3, a 4 or a 5. I could have that one with a 1, a 2, a 3, a 4 or a 5. That one with a 1, a 2, a 3, a 4 or a 5. And likewise the blue one, a 1, a 2, a 3, a 4 or a 5. So it says A prize is won if a spinner lands on blue or green and the other one lands on an even number. So we're going to look for which ones that is. So we've got blue and green, so there's blue in there and there's green in there. The other one has got to land on an even number, so it would be green 2 or 4 or blue 2 and 4. So this is for a prize. So out of all of them, to get a prize, you will win a prize if you score 4 different possibilities out of a total of 1, 2, 3, 4, 5, 10, 15, 20, 25. Now I want the probability of not getting a prize. So if it was 4/25ths of getting a prize, not getting a prize has got to be the rest. So not getting a prize is going to be equal to 25 of them minus those 4, which is going to be equal to 21/25ths. Oops, that's a 5 in there. Question 6. It says, Kenny buys a new fridge. The original price of the fridge is £650. The shop is having a sale with 20% off the price of all fridges. When Kenny goes to the shop, he finds there is an additional 2.5% off the sale price. Calculate the price Kenny pays for the fridge. Right, so we've got 2 things to do. We're going to work out this 20% off, and that's how much the sale price would be, but then he gets an additional 2.5% off. So we don't have a calculator. 20%, I want to work out 20% of £650. Now there's 2 ways you can do it. You can change 20% to a fraction, and 20% is 1 over 5 because 5 20s make 100, so 20% is a fifth. So I can work out a fifth of £650. I'm going to do my sum at the side of the page. So 650 divided by 5. 6 divided by 5 goes once and 1 left over. 15 divided by 5 goes 3 times. Nothing divided by 5 won't go. So that means you get £130 off the price of his fridge. Okay, so that's the discount. So the sale price at this stage is, it's going to be how much it was to start with, which is £650, take away the 130 that he's got off the price. So when I take them away, I end up with nothing take away nothing is nothing, 5 take away 3 is 2, 6 take away 1 is 5. So the price of it should have been 520 with that first sale. But then he goes to the shop and he finds that there's an additional 2.5% off the sale price. So I've now got to take 2.5% off this 520. So we want to work out, we'll just call it the other discount. So the other discount is 2.5% of £520. Now, I'm going to work out 10% of that, and then we'll see if we can change 10% to get 2.5%. So 10% is very easy to work out. So 10% of £520 is going to be, so 10% of £520, 10% is 1/10, because of nothing, that's easy to work out, is £52. But we don't want 10%, so I'm going to halve the 10%. If I halve 10%, I get 5%. So if I've halved that bit, I'm going to halve this thing here. So if it was a 5% discount, it would have got half of £52. Half of 50 is 25. Half of 2 is 1. So you'd have got £26 off. But it wasn't even 5%. It was 2.5%. But 2.5% is half of that again. So if I halve the £26, that would give me £13. So I now know he's got a further £13 off. So the sale price then is going to be, we started off with £520 and you get a further £13 off. So when I work that out, I've got to take them away. It's all in pounds. That would leave me with £507. So to make that one easier, you have to spot these connections, but it's easy to work out 10% and basically 10. If we half it, we get 5%, and if I half that, I get 2.5%, and it makes that question a lot easier. Biscuits are sold in tins in the shape of a cuboid, as shown. The tins need to be packed into boxes with the lid facing upwards. There are 2 types of boxes available with internal measurements as shown. Determine the maximum number of tins which can be packed. Use your working to justify your answer. So we want to know which box will give the most tins. Right, so we're going to look at this box here, the biscuit tin one. So it's 10 across, 10 back the way, and it's 15 up and down. And it's got to sit that way because the lid's got to be pointing up the way. So we're going to think about this going across here. Now it's the same distance across there as it is there, so it doesn't matter which way you take it. So how many boxes would fit across there? So 4 tens would be 40, so I can get 4 boxes going across there. That's 51, so 10 divided into that would give me 5. It can go 5 times. Let's get 50 centimetres up and down the way. So I want to know how many 15s in 50. So 1 15 is 15, 2 15s are 30, another 15 onto that is 45. If I put another one onto that, it's too big. So I can get 3 boxes going up the way. So if I count them all up, I just have to multiply them all. So 5 times 4 is 20, 20 times 3 is 60. So I'm going to get 60 boxes of biscuits into that packet. So next one, we've got 10, 10 again, so 45, 45 divided by 10, we can get 4 in there, giving us 40. That is 70 going across, so 72 divided by 10 would give me 7 boxes that I can put in there. And we've got 15 up and down the way, so 15 and 15 is 30, we can only get 2 up and down the way. So if we multiply them all together, we get 7 times 4 times 2. So 7 4s are 28, so I've got 28 times by 2. So 2 lots of 28, 2 8s are 16, 2 1s are 2, and 1 makes, 2 2s are 4, sorry, and 1 makes 5. So I can get 56 boxes in there. So I want to know what's the maximum of number of tins which can be packed. So use your working, so we can say that the maximum number is 60 tins of biscuits, and the working is all shown down there. So it's really box A that's the best one. Janet travelled by car from her home to a meeting. She arrived at the meeting at 10:15 a.m. She travelled 136 miles at an average speed of 40 miles per hour. During her journey, she stopped for 50 minutes for breakfast. Determine what time Janet left home. Right, so what we want to do is we want to work out the time for our journey, and then we'll add in the stop. So we've got our speed, distance, time triangle. It says ST at the bottom, like Saint, and then at the top is the D. So we want to work out the time for our journey. So we want to find out what that formula is. So we cover over time, and we look to see what's left, and it's D over S. So that means time is distance divided by speed. So the distance she travelled was 136 miles, and she did it at 40 miles per hour. So we want to divide that out. So if I divide top and bottom by 10, I'm going to have 13.6 divided by 4. So we'll do our sum at the side of the page, so 13.6 divided by 4. So 1 divided by 4 won't go, carry it across. 13 divided by 4 goes 3 times and 1 left over. Don't forget your decimal point. 16 divided by 4 goes 4 times. So it means it took her 3.4 hours. So that's 3 full hours, that's okay, I can do that. And to change minutes, this into minutes here, that's 0.4 of an hour. So we do 0.4 times by 60. And when I do that, it's the same as, just remember, take that 4, forget the decimal point, and times it by 6. So 6 4s are 24, so it's 24 minutes. Now that turns out to be exactly the same as doing 0.4 times 60, but it's easier just looking at that number and saying 6 4s are 24, so it's 24 minutes. Now, she stopped for 50 minutes, so the time taken for her journey was in total 3 hours and 24 minutes. But she stopped for breakfast for another 50 minutes. So when I add 50 minutes onto that, I'm going to take 10 minutes off there and add it onto there to make an hour. So it's going to be 4 hours. And when I take the 10 minutes off there, it's 4 hours and 14 minutes. So that was the total time that she was travelling, including the stop. Now it says that she got to the meeting at 10:15. And I want to know when she left home. So she got there at 10:15 and we want to work backwards. So we want to work back by taking away 4 hours and 14 minutes. So I'll take the 4 hours away first. So if it was 10 o'clock and I want to work out 4 hours before that, 10 take away 4 is 6. So it's 6 something. 15 minutes, take away 14 minutes, that's okay, that works out okay, so it's 1 minute. So therefore it means she left the house at 6:01 a.m. A design for a skate park ramp is shown. The height of the ramp is 70 centimetres, and it says to be suitable, the ramp must have a gradient of 0.35 plus or minus 0.01. Determine whether the ramp is suitable. Use your working to justify your answer. So this is tolerance. So we're allowed the ramp to be 0.35 plus 0.01. Or we're allowed the ramp to be 0.35 minus 0.01. So when I take that away from there, I've got 0.34. And I'm sorry, I should have been adding that one. Sorry, that should be 0.36 I was adding. So 0.36. And taken away, that's going to be 0.34. So the ramp is allowed to be between them. So it could be 0.34, 0.35, 0.36, and that's acceptable. And that's what tolerance is. Okay, so that's what we're allowed. Now, we need to work out the gradient. And the gradient of a line, and you're given this in your information sheet. So the gradient is the vertical distance divided by the horizontal. It tells you what the vertical is and what the horizontal are in your information sheet, but think of vertical lines as going up and down the way. So vertical distance is 70, that would be exactly the same for the ramp, so that's going to be 70 centimetres in there. Going across there, that's your horizontal distance, it's 2.1 metres. I've got to have these in the same units, I can't have centimetres and metres, I've got to have them both the same. So it's easier to change metres into centimetres. So remember, 100 centimetres is equal to 1 metre. So that's going to be 210 centimetres times it by 100. So vertical distance is 70 divided by 210. I'm going to divide that out because I want it as a decimal, so we'll cross off a nothing. That's like dividing top and bottom by 10. Now I can see 7 and 21, they're both in 7 times table. So we'll divide by 7. 7 into 7 goes once. 7 into 21 goes 3 times. Now I want to know what that is as a decimal. So 1/3 as a decimal is 0.3333, and it keeps going. Goes on and on and on. So is that okay? So the ramp has got to be between 0.36 and 0.34. Does that lie between them? Nope, because it's got to be in between them, so it's allowed to be 0.36, 0.35, 0.34. That is not allowed because that's down in here somewhere. So you would say, no, it's not suitable. And why is it not suitable? It doesn't lie. So the 0.333 is not between, and the two values that were allowed to be between were 0.36 and 0.34. Important you write that down to justify your answer. Next one is a precedence table, and it gives you different tasks, and you've got to fit them into this flowchart. So I've moved the flowchart from down here up to here. It says complete the diagram below by writing these tasks and times in the boxes. An additional diagram is required and can be found on page 17. So you always get an extra diagram to do these. Right, what you're looking for is you're looking for something to start. So preceding tasks, if you're starting, there's no preceding task, there's not a task that comes before it. So that gives you your starting point. So this bit will always tell you where your starting point is. So we've got to start with F. Now, the time that it takes to do that is 2, so I'll write a wee 2 in the box just to keep that done just now. So now we're going to look, and we can see from our diagram that there are 2 tasks where F precedes. So we're looking for the 2 tasks with F. So there's one there, and if I look down, there's another in there. I've got to do a wee bit forward planning because I don't know which one, so it's A and it's E. I don't know whether A goes in there and E goes in there. So what I'm going to do is I'm going to look at A because there's 3 tasks for A, but there should only be one for E. So I'm going to check them. So if I put A in there, is there's 3 places with A, 1, 2, 3. So that means it is A in there. And the other one is we've got to put in E. So the 3 tasks that we had for A, where we had B, and I'm going to check that they're okay in the right places in a minute. So we've got B, we've got C, and we have got the other A one is H. Now, I'm not sure whether H goes in that one. Those 2 are the same, pretty much the same, so it doesn't matter for B and C. But I've got to make sure that this is the right one that's in here, so it could be either B or it could be C. I'll do this one while I'm at it just now though. So E, what comes before E? So it's got to be G, so G goes in there. I'm now going to look and say, right, well, if that is H, okay, we want to find out where H is, and H is one of the ones where it's just got to precede D. So H precedes D there, that's all right. So that's straight to that one. I'm now going to look at this B. So can I find B on there? Yeah, B, I've got to have J. So I'll put J in there. And C, I want to find C. C is I, so that goes in there. So sometimes you've got to tweak them about, but that looks as though it's okay. Right, we'll need to put in some timings. So A, for task A, it took 1 minute. And then for task E, it took 1 minute. Put one in there. For task B, it took 1 minute. For task C, it took 7 minutes. For task H, it took 5 minutes. And then for task G, it took 1 minute. And for task D, it told us it took D. Now there'll be some sort of thing to say, either the maximum time or some other question on this. So we'll look and we'll see what it's asking us. So the part B of this, it says, John thinks that the team of mechanics will have the bike ready within 15 minutes. Determine if John is correct, use your working to justify your answer. So we're going to look back at that table and see if you can do this in 15 minutes. So we look at all possibilities. So if I'm going from F, that's 2 minutes, to A, that would be 3 minutes. Then up there would be 4 minutes. Okay, so I'll put wee 4 above that one. I've got to write in what G is. So G is equal to 3, and I missed out I, so I'll put I in there as 4. Okay, so counting that again, so we've got 2 minutes, 3 minutes, that would be 4 minutes, and that would be 4 plus 3 is 7, and another 2 would be 9 minutes. So that route would take me 9 minutes. This route here, 2 plus 1 is 3, 3 and 7 is 10, 10 plus 4 is 14, plus that 2 is 16 minutes there. If I go this route here, so I've got 2 minutes, 3 minutes, 3 minutes and 5 minutes is 8 minutes, plus that 2 is 10 minutes. And then F is 2 minutes, 1 minute, 1 minute, and another 2 minutes, which is 6 minutes. So it takes 16 minutes to complete all those tasks. So you're looking for the one with the longest number of times, because that's what you need. That's the time you need to do all of those tasks. So the question was, would he do it in 15 minutes? The answer is no, because it's going to take him 16. We'll write that in. it says, determine if John is correct. It'll take him 15 minutes. You would say no. It takes at least 16 minutes to complete all tasks. And you can say something like, that's a minute over the time he thought. Okay, so that's 1 min over time. Okay, so a wee sentence just to explain it. A survey was conducted into favourite pie fillings. The result were 80 people voted for apple, 40 for cherry, 60 people for lemon. Construct a pie chart to illustrate this information. An additional diagram is required at the back of page 18. Right, so we've got to see how many people were there in total. So we had 80, 40 and 60. So when I add all of them up, 80 and 40 is 120, 120 plus 60 is 180 people were surveyed. Okay, so that's the first thing you do. Now right away, I know getting right round that is 360 degrees. So every person has got to be 360 divided by 180. 2 18s are 36. So every 2 degrees stands for one person. Okay, so that might be easier to do that one. You can do it as a fraction as well. So 80 people wanted apple, so that's going to be 80 multiplied by the 2 degrees, which is going to be 160 degrees. For the cherry with 40 people, so that's going to be 40 multiplied by 2 degrees, which is 80 degrees. And for the 60 people for lemon, it's going to be 60, and we know every person stands for 2 degrees, so that's going to be 120 degrees. Now that should all add up to 360, 100, 200, 300, 360. So we want to get our angle measurer and measure out 160 degrees. I've lined up the angle measurer. Now you can see that the wee T shape in that part of your protractor, put that right on the centre there. Now go to where it says 0, so it's saying 0 out there, and count round your 10, 20, 30, 40, 50, 60, right until you get to 160, and I need to move this round. When you get to 160, put a wee dot, and then line that up with the centre. So I'm going to put a wee dot in there. So I've lined up the wee dot and I've drawn that in. So that's 160 people, and that 160 people represented apple. We prepared an apple filling. Now we do the same. So we can either start at that bit there and count around 80 degrees, or we can start down there, whatever's easier. I want to count around 80 degrees, so I've lined up the wee T bit on the dot again, and I've put the 0 line on this top bit. So I'm looking for 0, 10, 20, 30, and it's the inside scale this time. So 0, 10, 20, 30, 40, 50, 60, 70, 80. And I'm going to put a wee dot right beside 80, and then I'm going to line them. So I've lined that up. That is 80 degrees in there, and it looks okay. It's just less than a right angle, so that's fine. So that was for cherry filling. And I don't need to bother about the other bit because that's the bit that's left. So that was the 60 people that wanted the lemon filling. Just be careful, you're allowed a wee bit of leeway. So measure your angles out as accurately as you can. Laura makes and sells fruit smoothies. She intends to buy kiwi fruit in bulk. She considers the following two options. Option 1, 35 kiwi fruits for £5.95. Option 2 is 45 kiwi fruits for £8.10. Determine which option offers the best value for money. Use your working to justify your answer. So basically we want to find out how much one kiwi is with that and how much one is with that. Now £5.95, we're dealing in decimals, change it to pence, so it's 595 pence, and we want to divide that by 35. Now you never need to divide by long division, so you treat that as a fraction and you think of what number divides into the top number and into the bottom. So I can see that that ends in a 5, that ends in a 5. So they're both going to be able to be divisible by 5. So 5 into 35 goes 7 times. Now I've got to divide 595 by 5. So 5 into 5 goes once, 5 into 9 goes once and 4 left over, and 45 divided by 5 goes 9 times. So that turns out to be 119. But we've still got to divide by 7, so 119 divided by 7. 1 divided by 7 I can't do, carry it across. 11 divided by 7 goes once and 4 left over. 49 divided by 7 goes 17 times. So that turns out to be 17 and it's in pence. We do exactly the same for the other option. So we've got £8 and 10 pence. I'm going to do that as 810 pence divided by 45. So numbers that divide into 45 are 5 and 9. Numbers that divide into 810 are 5 and 9, or that could be 5 and something else, probably 9 as well. So I think what we'll do is we'll divide the 2 by 9, because it looks as though it's going to be easier. So 5 nines are 45, so that goes 5 times. 9 into that, 9 nines are 81, so that goes 90 times. So the sum I've got to do then is 90 divided by 5. It doesn't matter what order, you could have divided both in by 5 first. So 9 divided by 5 goes once and 4 left over. 40 divided by 5 goes 8 times. So that means option 2, they're at 18p each. So which option is the best value? So the best value comes from the one that's the cheapest. So the best value is option 1, because each kiwi was 17p, which is less than 18p. Okay, so which is less than 18p. Okay, and that's us. All the workings there to justify. This is the last question in paper 1. It says, senior students are preparing to sell scented candles at a school fair. Before ordering the candles, carry out a survey to find out which scent people preferred. The results of the survey are shown below. So preferred scent of candle, linen, vanilla, rose, cinnamon. Percentage of people, 50, 35, 10 and 5. So it says the students sell 180 candles in total. They sold 65 vanilla. Determine it as more or less than expected. So for vanilla, they expected to sell 35%. So we'll work out how many they expected to sell. So expected was 35% of, and it was 180. Now we don't have a calculator, so for 35% we're going to use our 10% to work it out. So 10% is 1/10, so 10% of 180, cross off nothing, is 18 candles. So for 35%, I've got 3 lots of 10, but I want a 5% as well. So 5% is half of that. So 5% would be the same as 9 candles. So for 35, I want 3 lots of the 10. So that's 3 lots of 18. And the 5% is another 9. So we'll count up and see how many that should be. So 3 lots of 18, 3 8s are 24, put down 4, carry 2, 3 1s are 3 and 2 makes 5, so that was 54 plus another 9. So 54 plus 9 would make 63 candles. Now the 63 candles was how much they sold. It says they expected, and that was the amount they expected to sell. They actually sold 65, so they sold 2 more. So determine, is this more or less than expected? So it was 2 more than expected. Or 2. Okay, so write your sentence down there. Okay, and I've explained it a bit more. 2 more than expected. The 65 is 2 more than 63. Okay, that's the end of that paper.